continue with example number 2. Now, in this example, I'm going to show you 2 ways. So I'm going to show you the way that we are expecting you to do it. We're also going to expect this factoring method when you are writing the equation of a given wave. And then I'm going to show you the other way that you can find on YouTube that is exactly the same thing. It works, but it is just different than what we are expecting of you. Again, mathematics is fantastic because there are many different ways to do, to solve things, to identify things. Go with the method that works for you, but I am also letting you know right now that we are expecting you to use the factoring method. Okay, and what do I mean by factoring is we need to factor out b. So if you recall in our beginning of the video, so in our video in the beginning, you notice that we have the general form as f of x is equal to a times sine of b times, you can't see that, b times x minus h plus k. So what we want to do is we want to pull out b out of x minus h, okay? So this is how we are going to be doing it. So how do you do that? How do you pull this out? So I'm going to rewrite this, and I actually just noticed that I forgot to put my f of x here. Okay, so how do you do that? So we're going to rewrite this 3 times sine of, and I know there's going to be a b value here, times something minus 1. And so how do you do this? The first thing you do is you look at the number in front of x or in front of theta. In this case, we have theta. So I'm just going to bring down our theta here, or our x. If theta is confusing you, and technically this should be theta here, because it's f of theta. If theta is confusing you, go ahead and switch it out for x. Just keep it consistent. So if you switch it out for x, keep it in x. If you don't do that. That's fine. Doesn't matter. Okay, so since they are using theta, I'm going to keep it in theta. If I change it in x, that might happen because I'm just used to using x. This 3, whatever this number in front of theta or in front of x is, you're going to factor 3 out. Keep the sign, that stays. And so now we need to figure out what this number is. So I'm going to do that off to the side in a thinking bubble. And what we are saying is when we distribute our 3, when we multiply, we will end up with 3 pi halves. So when I multiply 3 by something, I'm going to end up with 3 pi halves. So a easy way to do this is if you can see it, I hope you can see what this would be. If you don't, that's fine. What you can do is you can go back to Integrated Math 1 for this section of factoring and place in a variable. Make sure if you have x, don't use x, use something else. So let's actually use a different variable. Let's use, w. Let's use w. So we're trying to solve for w. What do? We need to divide by 3. And it looks like I'm running out of space, so I'm going to throw in another thinking bubble here. So I have a fraction divided by a whole number. That just means 3 pi halves is being multiplied by the reciprocal, which is 1/3. My 3's cancel out, so what do I have left over? I have pi halves. This value right here is what you're going to be putting in. Let me find a color for our h value. Okay, 3 sine of 3 times theta plus pi halves minus 1 is now what we are working with. Once you have factored out your b value, then you continue with all of the wonderful steps that we did in example number 1. So let's start. I'm going to shift this up, and I'm actually going to rewrite it without all my markings. It's just easier for me to see. So our example 2 now looks like f of x equal to 3 times sine of 3 times theta plus pi halves minus 1. I'm going to identify things right away. They might not be in the order listed on the steps, but we will identify everything. So first off, I need to identify my amplitude. Then I need to identify my period. Remember, period is not 2 pi. You are using 2 pi. Also, your period is not your b value. You are using your b value I guess you're using your b value and you're using 2 pi to find out what your period is. So in this case, there's nothing to simplify, so our period is 2 pi thirds. Our h, remember it's the opposite of whatever you see. If you see a plus, then it is a minus, so I'm going to the left, pi halves. And our k value is our midline, and it is exactly what you see, so our midline is at -1. So I did step number 1, identify your midline. I did step number 2, identify your asymptote. Step number 3 is identify your period. Step number 4 is identify your horizontal shift. So now step number 5 is apply your horizontal. So I kind of identify things, but I didn't mark anything up, so make sure that you are marking these up. So let's do that together. So here's my y, here's my x. Okay, so what are we doing? Step number 1, midline. So midline is at -1. Here's -1. That is our midline. Step number 2 is our asymptote. So again, we are going up 3 and down 3. So 1, 2, 3. Again, it's jumps. It's the distance. Don't just go to the number 3. That's not what that means. It means distance or jumps. So 1, 2, 3. That is our maximum. And 1, 2, and I'm going to extend this a little lower. So 1, 2, 3, I'm at -4, and that is my minimum. And just to make it look the same, I'm actually going to make this a little bit larger. Okay, so there we go. So we have 1, 2, 3 jumps. So 1, 2, 3 jumps. We have our max. So when it's asking you what is your max is the maximum, so it is at 2. Your minimum is at -4. Your midline is at -1. Now it's asking, we are still on step number 5, and your step number 5 is saying apply your h. So we are going to the left pi halves. So we are on our negative side, pi halves. And I'm going to draw a line there, a vertical line. So I am now in step number 6. And it says apply your period to your h. Okay, so what is our period? Our period is at 2 pi thirds. And this kind of looks like a z, and that's bothering me. So I'm going to change that to a negative pi halves. Okay, so we're now going to take our h, which is negative pi halves. We know let me back up. We know that our period is 2 pi thirds. We have already traveled pi halves. Gets a little tricky. Gets super duper tricky. Okay, I'm going to slide this over. thinking bubble time. All right, beautiful people. So we are in our thinking bubble and we're trying to figure out what the period is. We know what the period is. It's 2 pi thirds. We already did that. But we're trying to figure out where exactly it is our one full cycle going to end. So I know that I am starting at negative pi halves and I need to finish at whatever it is in order to get to our, excuse me, that's not right, in order to get to our finish line. So we need to figure out, we know that we are going to add 2 pi thirds to this in order to figure out where our end is. So I'm going to deal with fractions here by saying this is what? This is 3 pi 6 plus 4 pi thirds, and that's equal to 4 pi 6. And that's equal to pi 6. So it's going to end at pi 6. So I'm looking at my graph here, and I'm noticing that I don't have much negatives, and it looks like the majority of this is going to be in the negative. So I'm going to cheat a little bit because I have a pencil here, and I'm doing a little happy dance that I did do this in pencil. So I'm going to just bring my y-axis, oh, I don't know, somewhere over here. And a lot didn't change. Here's my 2, here's my negative 4. And I'm just going to sketch this out. Yay for pencil and yay for erasers. All right. So I know I'm going to end up in pi 6. So let's say this is right here, pi 6. And because I know it's the denominator 6, I'm going to convert this negative pi halves into our 3 pi 6. And then that's when we need to start cutting. Now it's going to seem a little bit weird at first how to cut, but if I am at negative 3 pi 6, I'm going to be at negative 2 pi 6, negative 1 pi 6, I'm going to be at 0, and I'm going to be at pi 6. So again, we're trying to get those 5 points that are evenly distributed or evenly placed. So if I go 1 pi, I am at 2 pi divided by 6. If I go another pi, I am at pi 6. If I go another, I am at 0. And if I go another pi, and I keep saying pi, what I mean by is the distance of pi 6. So if I go a distance of pi 6, I'm at negative 2 pi 6. If I go a distance of pi 6, I'm at negative pi 6. If I go a distance, I'm here. So then here is our ending. So we know where we start, we know where we end. All right, now what are we? We just marked off our ending, which is step 7. Number 8 says, look if your function is positive or negative. So I'm looking back up here. It is a positive function. So we don't need to reflect anything. We know that our 3 points, our ending, our middle, and our starting are all going to be on the midline. Don't forget where your midline is. Here is your midline. So we're going to end, and we're going to start on our midline. Now we're also going to be in the middle, So where's our middle? So if I go here, middle is negative pi 6. And then I'm going to, again, there's nothing to reflect. We don't have a negative function. So we are up to our max and we are down to our min here. And again, I am going to attempt a smooth curve here. Make sure you have arrows on both sides because it continues forever and ever and ever. All right, this is where I'm going to show you that there is another way of doing it. And by that, I'm just going to show you on Desmos that if you did not factor out that 3, it would still work, but your values are going to be different. So go ahead and factor out that B value in the beginning. Again, factor out that b value. Because your function is continuous, it will forever and ever be whatever it needs to be. These are exactly the same thing. It's just we are factoring out that 3. In our class, in our department, we are teaching you guys to factor out your b value. Please do that. If you don't, we might need to have a discussion as to why you're not factoring out your b value. All right, let me head over to decimals here. Now I did take a second to, there it is. I did take a second to type these in. And then because we are jumping by pi 6, I went in here and I changed my step to pi 6, literally type in pi divided by 6 and it comes up here. There is one thing that I do want to mention. Let me do our original. So the blue one is what we factored out, the 3. And it looks a little different than what we have. I mean, it kind of looks the same, but I want to point out that Desmos does not shift your midline. Okay, so we still have our x and our y. So when you come over to, what do we have? What did we originally have? Negative pi halves. Come over to negative pi halves, you need to go down to -1. Where's -1? Where's -1? -1. That's -2. Anyways, there should be a 4, 3, 2, 1, -1, and I'm not sure why it's not showing that up. But there should be a -1 here. That's weird. Anyways, -1. Where was I? -1, -1, -1. Then we have our min and we have our max, and those values should match. So it might not give you, it might not look pretty on Desmos, but go ahead and verify your answers, check your answers. And then I just want to show you, this is what I've been wanting to show you. If you did not factor out your 3, you do have to do other steps to figure that out. I personally will not be going through those steps because I don't want to encourage you not to factor, because we are choosing to factor as a department. So if you find other videos that don't factor, I'm just going to tell you that both of these, so here's the non-factored version, here is the factored version on top of it, and they are exactly the same thing. So if you see videos on YouTube that don't factor, that's fine, but we are choosing to factor. So make sure that you are factoring out your b value. All right, beautiful people, that is it for me today. I hope you enjoyed this video. Like, share, and subscribe. And make sure that you are practicing. I'm going to probably post some videos, not videos, I'm going to probably post a worksheet for you guys to complete. Make sure that you are following your steps. If any of these steps don't make sense, please reach out and ask for clarification. Also, if you catch a typo or I did a mistake, made a mistake, let me know where that occurs so that way I can learn from my mistakes and you can learn from my mistakes. And as always, I appreciate you watching this videos. I hope you have a fantastic day, and thank you so much for watching. Take care.